Okay guys, so today we are going to be continuing where we left off with tests of significance for proportions. We will be doing 2 tests together in full, and then you guys will do 2 tests on your own for practice. And so here is our first example. It says a potato chip producer has just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potatoes in the shipment have blemished, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemished. Carry out a significance test at the 0.10 or 10% significance level. What should the producer conclude? So in this case, we are looking for the percent of blemished. Oops. Oh my goodness. Potatoes. Our null hypothesis, HO, will say that percent P is equal to 0.08. Remember, null hypotheses always have to be equal, whereas our alternate, HA, will say that P is greater than 0.08. And so we are checking to see in any given truckload, is the population percent of blemished potatoes higher than 8? Because that will help this person decide, should they send away the truck or should they keep the truck? All right, our level of significance was given. It's 0.10. Now our 3 conditions. We did do a random sample of 500 potatoes. All right, for independent, we'll say 500 is probably less. Oops, not 50, 500. Less than 10% of all potatoes. That is in the shipment, right? In a whole truckload. And then for normal first we're going to find P hat, right? It said 47 out of the 500, which would be 80 or 94, 9.4% maybe. Let's check. Yep, 9.4.094. So to check to see that it's normal, we will do N 500 times 0.094, which we know is the 47, definitely greater than or equal to 10. And then again, 500 times 1 minus 0.094, which will be 453, which is also greater than or equal to 10. So normal. Okay, so yes random, yes independent, yes normal. Now our test statistic, remember, is a z-score. Z equals that p hat value 0.094 minus the assumed value 0.08 over that square root of p 0.08 times 1 minus p over n. All right, so 0.094 minus 0.08, and then the square root. So we'll do 0.014 divided by, that standard deviation is 1.1539 is what I'm getting for our z-score. So we're 1.15 standard deviations above the mean. So now on our standard normal curve, starting at 0, we are up at 1.1539, and because our alternate hypothesis said we'd be greater, we will shade to the right. Oops. All right, so then to find that p-value, we use normal CDF. Go from 1.1539 to 1,000 or 10,000 with a mean always of 0, standard deviation always of 1. So we go from 1.1539 and we get a p-value of 0.1242. Now 0.1242 is greater than our level of significance, 0.10, which means we fail to reject the null hypothesis. Okay, and so what's that mean? We have an inconclusive test. Right? We should tell that supervisor, maybe keep the truck, maybe don't keep the truck, right? We don't know for sure. We have no solid evidence that our sample percent will definitely be greater than 8%. Now, just to sort of add to that, we're going to run a confidence interval. Now, because it's been a minute, let's review our confidence interval formula. We always do, after a test of significance, a 95% confidence interval. That's just sort of general practice. So remember, we do p hat plus or minus the z-score that goes with that 95%, that critical value, times the square root of, now we're switching, p hat times 1 minus p hat over n. Right? And so we do that because that's all the value we actually have, whereas up here, remember, when we run a test of significance, we're assuming the claimed value is true. That's why we use that in our standard deviation formula. Okay, so we will do 0.094 plus or minus. I'm going to do inverse norm 0.9001, not 95, to get my critical value. And that's with the center. I didn't write the word center, but we get plus or minus 1.96 times that square root of 0.094 times okay, so this will be 0.094 plus or minus square root um, 0.0255. And so when we subtract, I get 0.0685, which is lower than that 8% threshold, meaning they would keep the truck, all the way to 0.1195. So 6.85%. To 11.95%, right? And so that just further shows or proves that we have an inconclusive test because our confidence interval bridges that 8% threshold. Now, if you're the supervisor, you would maybe say, okay, just to play it safe, we're going to send this truck back. But even though we don't have hard evidence that the total percent of blemished potatoes is higher than 8%. It might be, though, and so you sort of hate to run the risk. Okay? So inconclusive, which is like not ideal, but our confidence interval just proves that. All right, example 2 says, according to the Centers for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, he surveys a simple random sample of 100 students from his high school that has 1,500 students. He gets responses from all 100 students, and 40 say that they have never smoked a cigarette. Run a significance test to determine the conclusion that he can make. So here we are looking for the percent of students at his school specifically who haven't, we'll just say smoked, just because I'm running out a space, but we'll know smokes a cigarette specifically. His null hypothesis is going to go based on the CDC's claim that P is equal to 0.50. All right. And then he wonders if it is true. Let's see, does it give us direction? So it says, Taeyong wonders whether this national result holds true in his large urban high school. So that doesn't say he wonders if it's more or he wonders if it's less. He just wonders if it's true. So our alternate will be that it's not equal to 0.50. All right, we can use, let's say we use this time because it's not given to us, a 5% level of significance. And yes, he took a random sample. Oh my gosh, this stylus. Where N is 100 students. Independent, yes. That is satisfied because 100 is less than 10% of the 1,500 students at his school. And lastly, normal. Right, so out of his 100, 40 said yes, so P hat was 0.4. So we'll do 100 times 0.4, which we know is 40, greater than or equal to 10. That works. And then 100 times 1 minus 0.4 is 60, which also is greater than or equal to 10. All right. So now our z-score, our test statistic, will be that 0.4 minus 0.5 divided by the square root of 0.5 times 1 minus 0.5 over the n value of 100. Okay, so we know we'll have 10% or 0.1 up top. And now we do our big square root. We get 2. All right, so we're 2 standard deviations. Oh, wait. This should be negative 2. Because that numerator is negative. Right, 0.4 minus 0.5, negative 1. Or negative 0.1. So here we've got 0. We're down here at negative 2. All right, now here's an important thing. Notice or remember here we did not equal to 0.5 as our alternate. So when we draw this, we're actually going to look at both ends. Right? Remember, if it's less than, we shade to the left. Greater than, we shade to the right. Not equal to, we shade both ends. So now when we use normal CDF, I just find the far left end, so negative 1,000 or 10,000 to negative 2. And then I multiply that by 2 because it's symmetric. So what the shaded area is on one side is the same as the shaded area on the other. All right, so times 2 is 0.0455. Okay, now 0.0455 is less than our level of significance, 0.05. So here we are able to reject the null hypothesis, which means we are saying in Taeyong's high school that the percent of students who haven't smoked, right, is not equal to 0.5. We are proving the alternate is true. So P does not equal 0.5. Now, our confidence interval is going to help us figure out, what it actually does equal. So we have 0.4 plus or minus. Now, we don't even have to do inverse norm here because remember, if we do a 95% confidence interval for means, we already know, why am I writing I? That our critical value is 1.96. Okay, so now the calculator. I'm going to find the standard deviation. Multiply it by 1.96. I get 0.096. So 0.4 plus or minus, that is 0.331. So 33.1% to 0.469 46.9%. All right, and so because this does not equal 0.5, right, 0.5 is not in that, or 50% is not in that interval, that further proves that we should have rejected the null in favor of the alternative. Now, it even more emphasizes that not only is it not equal to 0.5 or 50%, but it's less because our entire confidence interval is lower than 50%. All right, so that's why we do these hand in hand. The test of significance tells us some results about the value of P, whether it's greater than, less than, or not equal to some claimed value. And then the confidence interval further narrows down the possible actual values for that parameter. All right, so see how you do on the practice. Hopefully we're feeling confident, we're understanding, and we're doing great.